Hey everybody, how you doing? Dr. Heldman here, Tech Talk Education. In this video, I want to begin going down the road of learning about networking, and specifically I want to talk about a subject that is not very near and dear to most anyone's heart that works in technology, but it's something that you've got to know, and so we're going to talk about the OSI model. It's very interesting. It's important that you understand how and why it works, and the components that go into it. So let's get started. So I'm just going to use a conventional PowerPoint slide deck for this because there's really nothing to get on the computer to work with in any way. This is more cerebral knowledge than it is getting in and physically getting your hands wet with it. But it's a very, very important subject that we have to talk about here. We're talking about a thing called the OSI model. It stands for Open Systems Interconnect, OSI. There's a model that is a complement to it. It used to be called the Department of Defense model, the DoD model, when I went through networking training for my Windows MCSE way back in the mid-90s. It was called the DoD model. Now it's called the TCP-IP model. They're two distinct different things. But the OSI model is the one that's actually the most popular. It's still in vogue, it's still talked about, so we need to understand how it works and what it is. Now this is what it looks like. So you have, on the left-hand side here, you have the OSI, it's called the reference model. And on the right-hand side, you have the TCP-IP model. And I would call it the DoD model. It's you might see it referred to in texts or whatever as DoD, Department of Defense. On the left-hand side, it has 7 layers. It's starting with the top layer, application, then presentation, session, transport, network, data link, and physical. You got to memorize those, and you've got to know what's happening at each level. Now, the idea is, as a user is interacting with a computer, doing something, and the most common thing we do today is we get on the web and browse, or we do a transaction of some kind, that what happens in each of these different sections within the OSI model is important, and so we need to know how that works. Then what happens is you need to do a compare to what the TCP/IP model, also known as the DoD model, how it compares to that. Some people think it's a little bit easier because, for example, here you have the application section of the TCP/IP model, and application comprises application, presentation, and session in the regular OSI model. Transport stands by itself, network transport stands by itself, but network interface consists of 2 things on the OSI side, data link layer and the physical layer. Data link is actually broken into a couple of other layers that really aren't necessarily for you to memorize, and then the physical layer. Now, some handy mnemonics that are very popular out there. A mnemonic is a way for you to memorize the order of things by memorizing some sort of a sentence that is easy for you to remember. In this case, starting from layers 7 through 1, we take the first letter of each of these, so here's A and then P and so forth, and what we do is we say all people seem to need data processing. If you can remember that sentence, what's going to happen then is that you can remember the order of these things as they're going along. Going up from layers 1 through 7, you'll remember, please do not throw sausage pizza away. Very common. They've been around for decades, and this is a really good way, a good mnemonic for you to figure out how these things work and the order in which they work. Now, the OSI model is used to describe a bunch of things. Let's talk a little bit about this. And I know this is a big slide, but the main thing I'm trying to get across here is that you can't just memorize each of the layer names. What you've got to do is figure out what the layer is responsible for, because there are coders and network people and other technical people that pay attention to these layers, and you'll wind up, as you work in information technology, you'll hear people talk about the different layers that are going on. This is for Transmission Control Protocol, Internet Protocol, TCP-IP. It consists of literally hundreds of protocols. It's not just the two. You've got to memorize quite a few of them. You've got to know what they do and what layers they interact at in the OSI model. Now, layer 7, the application layer, provides services directly to end users, and it enables interaction with network applications. So you could think of a web browser or Outlook mail, something like that. Layer 6 is the presentation layer. This is responsible for translating, encrypting, and compressing data. Layer 5 is the session layer, and this manages sessions between computers. It handles the setup and the coordination and the teardown or the termination of data exchanges. Layer 4 is the transport layer, and it means exactly what it says. It's getting things from one place to another. So it's ensuring reliable data transfer. Now there's two protocols that belong inside the transport layer. One is called TCP, Transmission Control Protocol. The other one is called UDP, Uniform Datagram Protocol. They do essentially the same thing, getting things from one place to another, but they do it in quite different ways. For example, TCP is a connection-based protocol. It's like you calling your mom on the phone. Everything is secure, and it's just you and your mom talking to each other, whereas UDP is more about we're just going to get the data to the other side. We don't care how it gets there. Once it gets there, it's reassembled. So that's the transport layer. Layer 3 is the network layer. Now you're going to hear people from companies like Cisco and others talk about network layer. This is where routers live. So if you have a big honkin' expensive router, or even your home router, it works at layer 3 of the OSI model. This handles logical addressing, forwarding, and routing. It decides how data is forwarded between networks using IP addresses. And today there are two different flavors of IP addresses. There's IP version 4, which is the old way, and then there's IP version 6, which is the new way and a little bit more complicated way, and you have to know about them both. Then there's layer 2, which is the data link layer. Now this is establishing a point-to-point connection. Now this is very, very interesting. I'm going to do a follow-on video to this to show you how this works, but computers have what's built into them what is called the media access control number. It's called the MAC address, and the MAC address, what happens is if you want to go and you want to connect to a server somewhere, anywhere in the world, the first thing you have to do is discover its MAC address. So it's hardware to hardware. Then you can get the IP address for that host, and then you can begin to communicate with it. It's absolutely amazing. It's quite complicated, and it's amazing how quickly, rapidly that it works. And then we have the layer 1. Layer 1 is the physical layer. This is the actual way that we get the signals across the wire, whether it's by cables or voltage levels or signals or other connector types. This is what it's. This is layer 1's. Now, here's some protocols. I told you that there's a lot of them. These aren't nearly all of them, but these are a lot of the common ones that you should be aware of. So at the application layer, you have Hypertext Transfer Protocol and Hypertext Transfer Protocol Secure. You have File Transfer Protocol, Simple Mail Transfer Protocol, and Domain Name System. These all function at the application layer of the OSI model, and at the DoD layer or the TCP-IP layer, these are all in the application layer. You have at the presentation layer a secure sockets layer, and it can also do data conversion. So we can convert from, say, ASCII to EBCDIC, for example. So the idea of converting between different data table types, the idea is that I have a character set that I keep. It's called ASCII. IBM developed a character set called EBCDIC. There's one called Unicode. And so the idea is how to convert between these different types. This is at the presentation layer, which in the DoD model is also the application layer. Then we have remote remote procedure call, remote RCP. I've got it misspelled there. It should be RPC. Remote procedure call. And then there's a thing called NetBIOS. And then structured query language, SQL, lives at the session layer. And again, in the DoD model, it's at the application layer. Remember that the TCP-IP model, the DoD model, encapsulates sections 5, 6, and 7. They're all called the application layer when we're talking about the TCP-IP model. TCP and UDP live at the transport layer. They are both transport layers, whether it's the OSI model or the DoD model. At the network layer, it's called the internet layer when we're dealing with TCP/IP, but when we're dealing with OSI, it's called the network layer. And this is where the Internet Protocol, ICMP, which is Internet Control Message Protocol, Routing Information Protocol, other protocols that pertain to IP addresses and getting addresses switched and swapped between one another. In other words, finding out where a machine lives, what its IP address is, and then routing to it. That's the dealio with the layer 3 network layer. Layer 2 is the data link layer, and it's responsible for things like the Ethernet command set. There's a thing called ARP, Address Resolution Protocol, point-to-point protocol. And the reason these are important is because what we have to do is we have to grab the MAC address off of our computer. Then we want to go find the MAC address of the computer that we want to connect to. That's quite a process. Once we have that, then we can begin to communicate using IP addresses. And then finally, the physical layer is at the very bottom. You can think of these as electrical signals or signals that are going out in some way, like over Wi-Fi radio signals, fiber optic light signals, copper would be Ethernet. So that's the physical layer. But essentially, it's signals that are going out at that juncture, ones and zeros. Now, this is all theoretically great, and it is theory, but I will tell you that it is baked into common networking around the world. So it's very, very important that you understand how this works. Now, let's just do a little example here. You're going to visit a website, and so you pull up a browser, and you're going to go out to HTTPS. That's the most common today. It used to be HTTP, Hypertext Transfer Protocol, which listens on port 80, but HTTPS listens on port 443. That's a secure transfer protocol. And so here's what's going on under the hood. So you launch a browser, Chrome, Edge, whatever. You type in a URL like example.com. The acronym URL stands for Uniform Resource Locator. It's just a great way for you and I to communicate together that we're talking about a website address. We just say URL. At the application layer, the browser uses HTTP over what is called transport layer security. There's an even higher one than this, SSL. And these are used to make the conversation secure. And so we're using port 443. You can think of these ports as logical holes that are in your computer by which we can communicate across one section, one number, and that protocol is tied to that number. So HTTPS typically is tied to port 443. HTTP is tied to port 80. We'll see those in just a minute. But the idea here is that at the application layer, HTTP is hooked together with TLS, and now we have an encrypted session. The layer also uses domain name system, which is the phone book of the internet, to find example.com and then to turn it into an actual IP address by which we can go and connect to that computer. Now, example protocols in the application layer are HTTP, HTTPS, DNS, File Transfer Protocol, and Simple Mail Transfer Protocol. At layer 6, the presentation layer, this layer encrypts HTTP data using TLS. If necessary, any data encoding that needs to happen is also handled at this layer. Examples of this would include UTF-8, ASCII, and of course EPSIDIC. There are others that are out there. Additionally, if any data compression needs to happen, it happens here. For example, if you had something that was using gzip, that might happen here. And example protocols in this realm are TLS and SSL. That would be Transport Layer Security and Secure Sockets Layer. You have an email thing called MIME. You have JPEG for, say, photos, and MP3 for audio. That's the idea at the presentation layer. Then we have the session layer. Session is established between a client and a server using what is called a socket. Now, a TCP socket, Transmission Control Protocol socket, consists of two things. There is an IP address, and then there is a port number that by which we are talking to the other host on the other side of the network. And so you need to remember that a socket uses an IP address and a port number. And generally speaking, the idea is that I can type in an IP address and then a colon and then whatever the port number is by which I want to communicate. This is all baked in at a certain level, but you can play around with this. As you get more sophisticated with this, you can try playing around with connecting to, other ports to see if that works. And this is a very intrinsic and important part of cybersecurity. And a TLS handshake takes place to initiate secure communication. The connected session is tracked using things like cookies or session IDs. Cookies are a pretty old hat. They're still dropped off quite a little bit in the world, but session IDs are the big deal today. And then what this does is it manages session initiation. Now, when we say session, you go out to the browser, you connect to Amazon, you log on, you now have a session with Amazon, and you have a session ID. And so this, at layer 5, this is how that session gets pinned up and how things get started. It's responsible for the coordination of the session as well as the teardown of the session once you're done. Now, I want to stop and just take a real quick minute to let you know that there are tons and tons and tons of port numbers. There are actually 65,535 of them. You don't need to know the majority of them, but there are many, many that are very, very popular here. I've put a list here for them, and then all of these have protocols associated with them. So in the first column here, you can see that I've got the port number. For example, if I'm using file transfer protocol for data and for control, FTP listens on ports 20 and 21 by default. It's called FTP. It actually takes up 2 ports, and then it's using TCP because it is a secure connected. It's not secure at all. It's actually completely unsecure, but you do have to log on to be able to connect to FTP. So the idea that you'll use TCP because you need to log on using FTP. Secure Shell is very, very common these days. It listens on port 22. It too uses TCP, so you have a username and a password or whatever. Telnet is extremely unsecure. If you find a machine running Telnet, you could easily get in and take control of that machine and probably burn it to the ground like this. It's pretty unsecure. Listens on port 23. SMTP, Simple Mail Transfer Protocol, on port 25. DNS listens on port 53. You get the idea. So you need to know these. You should also know that in one process, what happens is very often when you connect to a server or a machine somewhere, it's just going to make up a port. So you'll make up a port by which to connect to the opposite machine. It will make up a port. It'll answer on a port that's normal. For example, you want to connect to a secure website, you'll use HTTPS to connect, but then when the handshake and everything goes down, it might choose a different port, and these are up in the high 10,000s. Also, you can have your own port, so there are game companies and people like that that have ports that they have dedicated to just their particular application. This is a fairly good list. It's not all-inclusive. The main one that I think you should know about is 8080 here. And what happens is when companies have what is called an intranet, like a company newspaper, this is the place where you can go fill in a request for leave, or your time card or things like that. It's all done automatically, but it's done using a website that's inside the company. It's called an intranet. Very often, intranets listen on page 8080, and that's why it's called HTTP alt, because it is an alternative website that's being used inside. Now, layer 4 transport, this is where the TCP session gets an IP address. So the browser opens a TCP session to the server's IP address, for example, using port 43 for HTTPS, Hypertext Protocol Secure. The data now, this is important, is segmented into what are called TCP segments. So there's 3 words you've got to learn. Layer 4 deals with what are called TCP segments, and what this means is that they all have sequence numbers. Now, we're not talking about UDP. UDP, you could think of it as if you had a bunch of, say, Valentine's Day. You remember back when you were in school and you guys exchanged Valentine's Day cards, and you put them in a little envelope and you had like 20 of them and you just passed them out. UDP is, I'm just going to send this all out the door. It's going to go to wherever it's supposed to go to, and then it gets assembled wherever it got, however it got there. With TCP, it's secure. So the idea here is that we number all of these TCP segments in the order that they should occur, and then when they get to the other side, they're reassembled in that order for reordering. So this is the key component there. This ensures reliable delivery using acknowledgments and retransmits if needed. They're called an ACK and a NAC. So with TCP, the idea is, okay, I got packet 3, I got packet 5, I didn't get packet 4. I'm going to negatively acknowledge that I did not get packet 4. You've got to retransmit packet 4 to me, and that's the concept behind this idea of reliable transmissions and reassembling them. And the 2 key protocols are TCP, Transmission Control Protocol, and UDP, Uniform Datagram Protocol. Now at the network level, the client system wraps TCP segments into what are called packets. And if you're going to go into cyber, you really want to know what these packets look like. There's a whole bunch of things, sections to packets, and they have different areas that can be loaded up with different information. And so this is something that's going to be important for you to understand, especially if you go into cyber or into networking, because bad guys can put bad data into certain sections of a packet and send it across the wire, and it could be that your system doesn't even know about it, that it doesn't flag it or find it, and that's how this malware goes about doing what it's doing. Now, you determine the best route to the destination IP address. At layer 3, we are talking about IP addresses, so you need to remember that. Commit that to memory. Layer 3, IP addresses, whether it's a version 4 address, in this case, this is a version 4 address, 93.184.216.34. That is a legitimate address. I don't know who it belongs to, but it can be out on the internet. There are sets of IP addresses that are not allowed on the internet. And then it adds a source, a destination IP address to the packet header. We're not quite done, because as I said earlier, what we have to do first is we have to get the physical address of your computer, the MAC address. It's burned right into your network interface card. We have to go find the MAC address of the computer that we want to connect to. Then we can get their IP addresses, and then we can begin talking. I'm going to do a movie on that because that's actually a pretty involved process. It's quite interesting, it's fascinating, and it's amazing to me how fast it works. The key protocols here that you'll be worried about at layer 3 are the Internet Protocol, ICP, and ARP, Address Resolution Protocol. Then we have the data link layer. Now it converts packets into frames, and it attaches MAC addresses. So that the idea here is that you get your computer's MAC address, you attach it to the frame, and now you're like, okay, I want to go find whoever, example.com, where are they at? the very first thing that has to happen is I have to go find example.com's MAC address. Then, if I know the name of the domain, like example.com, I have to go find its IP address, and then I can set up the conversation between the two. If the server is on a different network, and this is what I was talking about with it, we need to see a video on this. If the server is on a different network, the destination MAC is initially the router's MAC. So the idea is that you go to the router and you say, this is my MAC, this is your MAC. And then the router says, okay, you need to go here, I'm going to give you this MAC, and you begin exchanging MAC addresses. But I want to do a little bit more with that, because that is quite the process. And at this level, data link layer is using things like Ethernet. There are a set of commands that go along with Ethernet, Wi-Fi commands, and PPP, which is point-to-point protocol. That's a WAN protocol. So at the physical layer, the data is converted into electrical, optical, or radio signals. Signals travel over a physical medium. Could be over Ethernet cable, which is copper cable. Could be over fiber optic cable, which is lights, or Wi-Fi, which are radio waves. And it's converted into bits. So at this juncture, it is all ones and zeros that are going across that wire. It doesn't matter if it's light waves, if it's radio waves, if it's physical electrical signals, it's all ones and zeros, because at the end of the day, everything you do on a computer is binary. It's groups of ones and zeros. That's it. It's amazing when you think about playing a game like Halo, or watching a Netflix movie or a YouTube movie or whatever, and every little bit of that is broken down into strings of ones and zeros. It's that simple. Now the components that are involved at the physical layer are cables, network interface cards, that's called a NIC. You can have a Wi-Fi NIC, you can have an Ethernet NIC. There are other network interface cards that are used for different sources. You can use radio waves, and then we keep track of the voltage levels as we go along, because if I'm going out over Ethernet, there are certain things that I have to keep track of in terms of the voltage level as the data is going across the wire. And then this is the way the whole process looks. Once we've gotten all this accomplished, then the reverse happens. So whoever you decided you wanted to connect to, now we do the reverse of it. The signals are interpreted at layer 1, frames are decoded, IP routing is resolved, TCP session is reassembled, TLS session is maintained, HTTP request is parsed. Okay, now we're there, and the server's like, okay, good, I know who you are now, and I'm all connected up with you. Now what do you want? And the server then retrieves the requested content. It's going to be in the form of things like hypertext markup language, cascading style sheets, images, JavaScript code, PHP code, things like that. And then it builds what's called an HTTP response, and it encrypts it with TLS and sends it back to you down to layer 1. So then you get it, and you have to bring it up through layers 1 through 7 to look at what you've got. Now think about this. This process is incredibly convoluted. There's a lot to this, and yet it happens nearly instantaneously. That is really the magic of the internet, I think, how very, very quickly this stuff happens. And in fact, you get frustrated, don't you? I know I do, if things seem to be going a little bit slowly. But when you see this and you understand what actually is going on under the hood with this stuff, it's actually amazing that anything gets done at all, isn't it? So that, I think it's just truly amazing. Now, thank you for watching. If you're enjoying these movies, I love creating these movies. I really enjoy talking about technology, partly because it forces me to learn new technologies, which I love, love, love. I love sharing it with you guys. I don't know where you're at in the whole scheme of things, if you're just now learning about IT or if you've been in IT for a long time. I can tell you that I am a former Microsoft certified systems engineer from way back in 1994, And I was learning things even when I was teaching kids in the high school classroom about networking and databases and things like that. I was just continuously learning. And IT is a continuous learning path. You're never going to get off the learning bandwagon because it just keeps going and going and going and going. So I really appreciate you guys tuning into my channel. I try to make it as easy for you to digest as possible. Some of the stuff is really big. The next video we're going to talk about this resolution of MAC addresses, and that is quite a thing, and it involves a bunch of routers going across the world, so it gets pretty involved. Also, if you would share this with others, I would love you for that. Thank you for that. If you had subscribed to my channel, set up a notification for yourself so that you can you get alerted when I put out new videos. And you know what, you're welcome to comment on these videos. Thank you so much for watching mine, and I appreciate it, and I will talk to you in the next movie. Have a great and wonderful day.